Most industrialized nations have established a national EV infrastructure program that includes charging stations along major roads in many cities and at shopping locations, stadiums, hotels, and other public facilities. In the United States, we have no national program, but private efforts to create an EV charging network are ongoing. For example, Tesla Motors has been building its own national infrastructure of EV superchargers and already has over 200 in place in the United States and more than 130 in Europe. But in this mini course, we won't be discussing national charging programs. Rather, we'll spend a little time much closer to home, your home to be exact. How much of a home infrastructure must you build to accommodate your EV or PHEV? That's a question we'll answer in this mini course. Your charging infrastructure begins with the grid and moves outward toward your home and ultimately to your EV. Unless you have a solar PV system or a generator, the grid provides all of your home's electrical energy needs. Current flows into your home through a service panel that distributes it to each of the circuits in your house. In general, the service panel is in your basement, or if you're lucky, in your garage. Why is a garage lucky? Because the cost of running a dedicated circuit for an EV charging system is directly proportional to the length of the electric cable needed to reach the charging location and the routing problems to get from the panel into your garage. You'll need an electrician who will install a 40 amp circuit breaker in your panel. Unless you're an electrical contractor, this is not a DIY project. The electrician will then run cable from a 240 volt, 30 or 40 amp circuit to the location where you'll be charging your EV. Then, depending on the type of EV you have, you'll either need a 240 volt receptacle like a NEMA 1450 or a charging unit, properly called Electric Vehicle Service Equipment, or EVSE. Let's talk about all of this in a bit more detail. First, a few general comments. You'll charge your car almost every day, usually overnight. But as I mentioned, to get that done, you'll need to create your own home charging infrastructure. Every EV comes with a charging cable that plugs into your EV's charge point at the EV end and into the grid via your home infrastructure. That connection can be an SAE standard J1772 plug in the United States with appropriate adapters. As an aside, the Tesla Model S uses a special plug designed by Tesla Motors, or an external charging unit, what I referred to as an electrical vehicle service equipment, EVSE, from which you draw power for your EV. The EVSE uses a J1772 plug in most instances. Before beginning this panel, a suggestion. If volts and amps are a mystery to you, please be sure to take our mini course, EV102, that explains these concepts in simple language. Two charging options exist for your home, 110 or 240 volt. Charging from a 110 volt circuit is very inefficient and very slow. Without getting into the physics of what's happening, a 110 charge wastes about 30 to 40% of the electricity it uses as it charges. So for example, if you need a 20 kilowatt hour of charge to top off your battery, you'll need to draw 26 to 28 kilowatt hours to get it done. Worse, it will take a very long time. Typical time to fully charge a small EV using a 110 circuit is 12 to 18 hours. With a 240 volt circuit and an EVSE, typically 3 to 4 hours. That's significant. Therefore, it's much better to charge from a 240 volt circuit. EVSEs, also called level 2 chargers, connect to a 240 volt circuit. Some level 2 chargers are 16 amp for use with PHEVs like the Chevy Volt. and can often be installed on an existing house circuit. Others are 30 amp and generally require a dedicated circuit to run directly from your service panel. Let's take a look at your charger. An EVSE is mounted on your garage wall, connects to a 240 volt line, and typically contains a J1772 plug. It communicates with circuitry inside your EV to ensure that the proper amount of current is passed to the EV, and it costs between $500 and $1,000 plus installation. There are many EVSEs on the market: Aero Environment, Clipper Creek, Bosch, Eaton, GE, Schneider Electric, and Siemens, among many others. All offer EVSEs for use with a variety of small EVs. But EVSEs are not required for every EV. The king of EVs is the Tesla Model S. By virtually any measure, it leads the pack. The Tesla Model S does not require an EVSE for 240 volt level 2 charging because all of the EVSE circuitry is on board the car. Tesla has developed its own charging cable standard. All that needs to be installed in your garage is a NEMA 1450 240 volt 40 amp circuit or something similar. All Tesla superchargers except the Tesla standard plugs. In part 2 of this mini course, we consider a discussion of how to build your charging infrastructure.